Okay, so let's go over the questions that we did on the pre-test. It says which is not a chemical change, and for this you should have a mental model of chemical changes: burning, rusting, digestion or eating, and oh my gosh, I can't even think of the last one. Cooking. Okay, so burning, rusting, digesting, and cooking. So what you have to do is look at the one that it's not. Okay, so copper turning green in air. Well, that's rusting or burning, because actually you're oxidizing. Baking a cake is cooking. Drying clothes, that's neither of those, so that's not. And exploding dynamite is burning. So all these are chemical changes. Drying clothes is not a chemical change, and this is what it says, which is not a chemical change. Okay, number 2. Use the figure below to answer question 2. The figure above shows models of molecules in a chemical reaction. So this is a molecule, this is a molecule, this is a molecule, this is a molecule. How would you describe this reaction? Okay, so you start off with something with a carbon and 4 hydrogens, and it's added to 2 oxygens, so those are the reactants. And then the products are a carbon with 2 oxygens and an oxygen with 2 hydrogens. Completely different things. So when you end up with something completely different, it's a chemical change. Okay, the reaction between hydrogen chloride and sodium hydroxide is shown below. The name and mass of each substance is involved in the chemical reaction are shown. What mass of hydrogen chloride was used in this reaction? And don't forget, the law of conservation of mass says the things on this side need to equal the things on this side of the arrow in a chemical reaction. Okay? So if you look here, you can just do mental math. 40 from 58.5 is 18.5, and 18.5 plus 18 is 36.5, so B would be the answer in that case. Okay, so the next one, which occurs before new bonds can form during a chemical reaction. What you need to do is make sure that you understand that in a chemical reaction, the bonds that are already there in the reactants need to be broken so that they can form new bonds. So think about our party. When we have molecules going to a party, they're actually attached to one another, and then when they get to the party, they mingle. Okay, so they leave each other's side. So the bonds between them are broken. So that is the answer to that. The bonds between the atoms in the original substances are broken. Which can be used to speed up a reaction? Okay, we talked about this. In order to get things to move faster, we need to heat them up, and because they move faster, they collide with one another, come in contact with one another more frequently, and increases the chance to form a bond. So if you increase the temperature, that is what happens. Okay, preparing a meal involves both physical and chemical changes, which involves a chemical change, just like our 4 things that we talked about before: cooking, burning, rusting, and digestion. Okay, so if you look at these, boiling water just changes the state of the water. It's still water, it's water vapor. So this is a physical change. Making ice cubes, again, you're changing the state, so it's a physical change. Slicing a carrot, it's still a carrot. It's just sliced up, that's a physical change. Toasting bread, you're actually cooking it, so that's a chemical change. So I is a chemical change. Okay, number 7, the law of conservation of mass states that in a chemical reaction, the mass of the reactants equals the mass of the products. If approximately 20 grams of water reacts in the equation below, okay, so we've got 20 grams of water, producing about 15 grams of oxygen, okay, so this is 15. What mass of hydrogen is produced? So these two must equal this side, so it's 5, which is B.